Hello students, welcome to the lecture number 11 on chemical equilibrium. In this lecture we are going to discuss the very important thing in this chemical equilibrium chapter, that is how any factor that is determining the equilibrium of the system, when we want to change all those factors like concentration of the reactants and product, temperature, pressure, all the things, suppose we want to change it, or in circumstances comes when it has changed, then how the reaction is going to respond with these changes of the factors. So today's lecture that we are being concentrated on those effect of different factors on the equilibrium. So in today's lecture we are going to discuss the effect of change of the factors on the equilibrium. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Suppose a reaction has achieved the equilibrium, we can say the system has achieved equilibrium. At that time, when we change any factors, that is its concentration of the reactant and product, or we can change some pressure, we change some temperature of this reaction, then how the reaction is going to respond? Naturally, the reaction or system will no longer in your equilibrium. A net reaction will proceed in that direction where the changes will be overcome by the system and it will going to get a new equilibrium state, that is, we can say that equilibrium is re-established. So in this case, how the reaction proceed, whether reaction will proceed in the forward direction or in the reverse direction, that is basically governed by a very important principle. This is called the Le Chatelier's principle. Le Chatelier's principle. From this principle, we can able to predict about the course of the reaction. The reaction, how the reaction will proceed, that we can able to predict from this Le Chatelier's principle. What it tells? It tells any change of factors, any change of factor that determine the equilibrium of the system cause to change the system so that to reduce or counter balance the impact of changes. Impact of changes. Any change of the factors that determine the equilibrium of the system cause to change the system in that fashion to reduce or counterbalance the impact of the changes. If we add some reactant, if we remove some product from the system which is in equilibrium, how this will going to be affected, how this system is going to be changed itself, that can be easily be predicted by the Lorentz principle. First, we will understand the effect of the change of concentration. Effect of change of concentration. Effect of change means we can add reactant to the reaction chamber, or we can remove the product from the reaction chamber. When we add some reactant into the reactant chamber, what is going to happen? The equilibrium will be disturbed. And this stress in the concentration has been imposed by the addition of this reactant is relieved by a net reaction towards in that direction where the added substance will be consumed. In that way, there will be a minimal changes in the equilibrium will be established. And in case of when there we remove some reactants, some product or some reactant, what is going to happen? There will be a net reaction will be on the way in that direction where this replacement of the replenishment of this removed substance will be recovered. So net reaction will be on that direction where there is a deficiency or there is a consumption of the material will be there. As for example, you can take the example of hydrogen and iodine. This hydrogen iodine, it will produce the hydrogen iodide and it is in suppose equilibrium. I take a graph of this. Here you can see this is at the equilibrium position. This is suppose hydrogen and this is iodine and this is HI. And here you can see this is a equilibrium. At equilibrium, this is a concentration and this is a time axis. And it is in equilibrium, and you can see that there is a consistency of the concentration of the hydrogen, iodine and HI. Suppose at this point we add some hydrogen. We add some hydrogen, and what is going to happen? The equilibrium will disturb and more amount of iodine will be consumed.
So you can see at this point the equilibrium is disturbed. Equilibrium is disturbed, we can say. And here we add the hydrogen. So what is going to happen? The net reaction will proceed on that direction where the hydrogen will be consumed, and that can only be consumed when there is a reaction with the hydrogen and iodine, and it will goes in this direction and more hydrogen iodide will be produced, and the concentration of in the equilibrium mixture will be changes. So in this case, when we add the hydrogen, what is going to happen? There is a forward reaction is on the way. We can say forward reaction. When we add the hydrogen. And in case if we remove this HI, hydrogen iodide, then also this forward reaction will be there, and it will be on the then also the hydrogen and iodine will react with each other and it will make a forward reaction. But if we take out some iodine or hydrogen, then what is going to happen? Then reverse reaction will goes on. So in this way there is a impact of the added substance in the equilibrium. Okay. Now this, whether this is in the forward reaction or in the back reverse reaction, that can only you can also predict from the reaction quotient also. The reaction quotient you can see here. Now when we add this hydrogen, so reaction quotient will be less than, in this case reaction quotient will be less than the equilibrium constant. And we know when the reaction quotient is less than the equilibrium constant, then what is going to happen? The forward reaction will be there. The reaction will be proceed in the forward direction and more amount of HI will be produced. So in this way we can able to understand, if we change the concentration of the reactants, or we can change the concentration of the product by removing the product, there will be the change in the equilibrium concentration. Before it was, you can see hydrogen have before the hydrogen concentration, and after the re-establishment of the equilibrium you can see this hydrogen concentration, this is different, and you can see hydrogen iodide also increased in this fashion. So this type of things that we need to understand, because in the exam what we'll do, we will do some numericals and you can understand how this type of question will come, that we will discuss later on. So now we understand, if we change the concentration of the hydrogen, or you can change the concentration of iodine, how the reaction is going to respond, and that is well explained through the Lorentz principle. Now we will discuss what will be the impact when we change the pressure of the reaction. Impact of pressure on the equilibrium can only be observed for the gaseous reaction, and not all the gaseous reaction, where you can see there is a difference in the total mole. The mole of reactants is not equal to mole of the product. At that case, you will find the change in the impact, change of the pressure on the equilibrium. When the inner total mole of the reactants is not equal to the total mole of the product, at that case you will find there will be the impact of the pressure, means the equilibrium composition will be changes. And in case of heterogeneous reaction, there is no such impact,
because pressure don't have any impact on the volume of your liquid or volume of the solid. So in this case, in the gaseous reaction, we can see the impact of pressure on the equilibrium. Let us take an example. This is the example, carbon monoxide when reaction with this hydrogen, and it will going to produce the methane and H2O gas. These are all the gaseous reactions. So in this case, you can see one thing, that 4 moles of carbon monoxide gas plus 3 moles of H2 gas produce the 1 mole of CH4 and 1 mole of H2O gas. So you can see 4 moles of this, 4 moles of CO2 and H2 gas, CO2 and H2 gas. Among them, 1 mole is CO and 3 moles is H2, produce the 1 mole of CH4 and 1 mole of H2O, means 2 moles. So we are producing from the 4 moles of the reactants to the 2 moles of the product. So you can see here the total number of moles of the reactant and total number of moles of the product is different. In that case, when we increase this pressure, suppose the pressure has been increased. Here, by how do we increase this pressure? By decreasing the volume. By decreasing the volume of the vessel, by decreasing the volume by 1/2 of the original volume, 1/2 of original volume. So pressure will be increased, pressure will be doubled. Okay, pressure will be doubled. So the partial pressure of the gas will be doubled, and accordingly the concentration of the reactants will be doubled. So at this condition, the equilibrium will be disturbed, and here will be the reaction will going on. After that, the reaction will be re-established. Then question arises, in which direction this reaction will proceed? For that, we have to remember the Lagrange's principle. It tells any changes, any impact changes, that will be taken care by the reaction, so that the impact of the change will be minimized. Here what we do now, we have increased the pressure, so reaction will be goes from this higher mole to the lower mole side, because we know pressure of gas is directly proportional to the moles. So when the mole is reducing at that point, means the pressure at that point will going to be reduces. So reaction will goes on that point, on the direction where there will be the reduction of the pressure, means reaction will goes from the higher mole to the lower mole. So that is where we can say forward reaction will be preferred.
forward reaction will be produced, forward reaction on increasing the pressure, because in the forward reaction we see there is a decrease in moles. 4 moles of this CO and H2 gas will produce 2 moles of CH4 and H2 gas. So this reaction will proceed on the forward direction and forward reaction will be on the way. So with the increase in pressure, forward direction reaction will be there and more amount of product you will observe. So in this case, more amount of product you will observe. But there is another reaction I will tell you. For this reaction, you can see here the 2 moles, the product is 2 moles and the reactant is 1 moles. Because it is a solid, you cannot have to consider it. So what is going to happen when we increase this pressure in that reaction? What will there? The reverse direction, reaction will go in the reverse direction, because it will go to the reaction will proceed in that direction where there will be the lesser moles. Here you can see the product has the higher moles, the reactant has the lesser moles. From the 1 mole you can have the 2 moles of CO. Here is different, 4 moles of this will create the 2 moles. So that will depend on this. So we can understand from this discussion that when we change the pressure, the impact on the equilibrium will be for those reactions which is gaseous reaction, and there is a change in the moles. If the moles is changes from the reactant to the product, means from the reactant is higher mole, product is the lower mole, then reaction will be going in the forward direction, and it is reverse that you can see here from that. In this case 1 mole of CO2 produce the 2 mole of CO. At that time you will find on increasing this pressure the reverse reaction will be there. But for this reaction H2 plus I2, this is also gaseous reaction. Here you can see there is no change in the moles. So in this case there will be no impact of the pressure. Okay. So in this video now we are able to understand the impact of the concentration and impact of the pressure on the equilibrium points. Right. Now we will do some numericals. Question number 1. For which of the following system of equilibrium at constant temperature doubling the volume will cause a shift to right? Means the equilibrium will be the forward reaction. Equilibrium will go to the forward direction, means you have to find out with the doubling of the volume which of the reaction will have the forward reaction, not reverse reaction. For that, what we have to do for this type of, we have to first do the reaction quotient, right? From the reaction quotient you will have to see whether the reaction quotient is less than or greater than the equilibrium constant. And for all the things, for this you will find the reaction quotient. When we are doubling the volume, we will find the reaction quotient will be same as the your equilibrium constant. For this you will find that is different, that is it is reaction quotient will be, for that let us calculate the reaction quotient. That's CO2 concentration of this concentration and this. So this is reaction quotient 1, that you can see that is equal to the equilibrium constant. And when the volume is double, so what is going to happen? The concentration will be reduced. So in this case, the reaction quotient, you can see the reaction quotient is more than the equilibrium constant. This you can say this is equilibrium constant. More than the equilibrium constant means the reaction goes on the reverse direction, in this direction. The equilibrium will shift from the left to right. For this case also you will find this will left to right. But here for this you can see the reaction quotient is less than the Kc. When you calculate this, let us calculate the reaction quotient for the option D. Here Kc you will find that is concentration of PCl3 gas into concentration of this gas, Cl2 gas, and concentration of PCl5 gas. Now what is going to happen? The reaction quotient. Reaction quotient is, you can, when concentration is reduced, so you can write this PCl5, this concentration is half, Cl2's concentration is half, and PCl5 concentration is half. So you can get the concentration of PCl3 and concentration of PCl2, and you get the PCl5 concentration, and you can see this is 2 into 2 means half. Means this is Kc is less than the Qc is less than the Kc. You can write Qc is less than Kc. So in this case, this will be the right answer, that here for this case, when you doubling the volume, the will cause the shift to right. The equilibrium will, okay, it will shift to the right. Okay. So this is the reaction SO2 gas and Cl2 gas. SO2 Cl2 is exothermic. This is the reaction SO2 gas and Cl2 gas, and it will produce the thionyl chloride. SoCl2 is exothermic and reversible. A mixture of SO2 gas and Cl2 gas and SO2 Cl2 liquid is at equilibrium. Now quantity of SO2 introduced. What will be the true among these four conclusions? The pressure inside the container do not change, the temperature will not change, temperature increase, and the temperature shall decrease. See, when we put some Cl2 gas in this reaction which is in the equilibrium, what is going to happen? The forward reaction will be on the way, and as it is an exothermic reaction, then there will be the temperature increasing in the temperature. Okay, today's video. In this lecture, we have discussed about the increase of the concentration and the pressure, along with some typical numericals, that is going to, this type of numericals going to come in your exams. Next lecture we will discuss about the other factors, that is the temperature and impact of catalyst and impact of your inert gas. Okay, thank you very much for watching. Thank you.